Hi. All right. Hi, sixth grade. So today is Monday, April 20th. Are you happy it's Monday? We're together again, at least on video. I hope you had a restful weekend and you're ready to work. All right, so what we're going to do first is we're going to derive the formula for the area of a parallelogram. Just like how there's a formula for the area of a triangle, we also have a formula for the area of a parallelogram. Let's watch this video.
Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're going to talk about the area of parallelograms. Let's get started. On parallelograms in general, okay, especially with how to find the area of them. So first, what exactly is a parallelogram? It's a quadrilateral that has two pairs of parallel sides. Those sides, the opposite sides, also are the same length. Now let's talk about how to find the area of a parallelogram. And to start, we're going to start with a rectangle. Rectangles are parallelograms. But we want to know how to find the area of a parallelogram that is not a rectangle. So if it looks a little bit different. So what we can do is start with a rectangle, and we know how to find the area of a rectangle, length times width. You've done it since probably 4th or 5th grade. But what if it looks different? What if we cut off a triangle from that rectangle with a little chop? Now that we've got a rectangle and actually a trapezoid, if I move that rectangle and those right angles line up on the other side and we put it together, this is a parallelogram. Did we change the area from the rectangle that we had before? And the answer is no. It still covers the same amount of space. The area is exactly the same. We just moved some of it from one part to the other. So now let's talk about how to actually find the area of that. So here we go. The area of a parallelogram is just the product of its base and its height. And we know product means multiplication. So area of a parallelogram is equal to base times height. Okay? Now notice we don't use length and width. And there's a reason for that. Okay? One is, if you look at this, and I ask you, well, what's the length and the width? You would say, well, okay, well maybe this we could call the width. Is this a length or is that a length? And you get confused, okay, because it doesn't have right angles. We use base and height. And the key is the base. Oftentimes you think of it as the bottom, right? But it doesn't have to be. I could rotate this up and it could look like that, and this could be the base. Okay, it doesn't matter. Bases could be different lengths depending on how the shape is written. Okay? But for here, that's going to be my base, and my height. This is the key. The height has to be perpendicular to the base, which means it needs to form a right angle. So this is not my height. Okay, that is my height. And it makes sense, right? If we think of ourselves, if I go to the doctor and they're going to measure my height, they don't take a ruler, or not a ruler, but a tape measure, and measure from over there diagonally up to the top of my head. They make me stand straight, and they measure perpendicular with the ground, straight up. That would be your height. It'd be great if they measured it from over there, because I'd be a lot taller, but that's not how they do it. So here, if this was my base, my height would be right there. And that's how you find the area of a parallelogram. All right, example one. Find the area of each Well,
Okay, so in summary, the area of a parallelogram is base times its height. And remember, the height has to be perpendicular to the base, and or you can denote it as b times h. Okay, so now let's find the area of a parallelogram with an example and with our guided practice. I'm just going to make my video a little bit bigger because I'm going to be doing some work on the whiteboard so you can see maybe more clearly. So in the figure, ABCD is a parallelogram and line BE is straight. Okay, so how do we do this? Well, first we have to find the height. Okay, which one is the height? Is AB the height, or is DE the height? The height of the parallelogram is DE. DC is not the height of the parallelogram. AB is not the height of the parallelogram because DC, AB are not perpendicular to the base BC of 8 centimeters. So BC is the base, which is 8, and DE is the height because it's perpendicular to the base, which is 4 centimeters. And so what do we need to do here? Okay. Well, remember the area of a parallelogram is equal to base times height, okay, which is the base is 8 and then the height is 4, and that would be 32 square centimeters. All right, let's do guided practice. Numbers 1 and 2, pause the video. When you're ready, play it again. Hey, welcome back. All right, so we're going to do numbers 1 and 2 at the same time. And first, let's determine the base of parallelogram 1 and parallelogram 2. I'm going to determine whatever is facing the floor as the base. Okay, so I count 4 units as the base for number 1 and 3 units as the base for number 2. Next, we have to figure out the height. Remember, the height is perpendicular to the base. So that yellow line is perpendicular to the base. So I count 7 units for the height for number 1 and 7 units for the height for number 2. And then I'm going to input in those values into the formula for the area of the parallelogram. So for number 1, it becomes 4 times 7 is 28 square units. And then for number 2 is 3 times 7, which is 21 square units. How'd you do? Did you get the same answer? Yay! All right, let's do guided practice numbers 3 through 4. Pause the video and I'll see you soon. Hi again. All right, so just like numbers 1 and 2, we're going to do 3 and 4 at the same time, okay? So first off, I want to determine the base, and again, I'm going to determine it as the side that's on the floor. Just like the guy said in the video, any side can be the base, but just so then I can be consistent and so you can really understand, how to determine the area of a parallelogram, I'm just going to say, just pick a side that is on the floor. Okay? And so the base for number 3 is let's see, 4 units, and then the base for number 4 is 2 units. And now let's determine the height. Remember, the height is perpendicular to the base, and so these yellow lines are perpendicular to the ground, right? On the same ground or floor that the base is lying on for each of the parallelograms. And so the height for number 3 is 8 units, and then the height for number 4 I see is also 8 units. And then we're going to input in the base and height that we found into the formula for the area of the parallelogram. And for number 3, it's 4 times 8, which is 32 square units. And for number 4, it's 2 times 8, which is 16 square units. How do you guys see? All right. And now, finally, this is the last set of guided practice. Pause the video and I'll see you soon. Hey, welcome back. All right, so just like we did with numbers 1 through 4, we're going to do 5 and 6 together. Okay, so first off, I want to determine the base of those two parallelograms. So I'm going to determine QR to be the base for number 5 and XY to be the base for number 6. So for number 5, the base is 21 centimeters, and for number 6, the base is 24 centimeters. Now, maybe the tricky part might be, which one's the height? They are giving us 2 different pieces of information that could be the height for number 5, and 2 different pieces of information that could be the height for number 6, okay? Now to determine the height, okay, I see, well, okay, for number 5, it could be PQ or it could be ST. For number 6, the height could be WX or it could be YZ. Do you see that? Okay. Oh, not WX and YZ. It could be just that line, that dotted line under Z, okay? So which one is the height out of those 2 choices? Well, I know the height has to be perpendicular to the base, and so I determine my base to be flat on the ground, so it needs to be straight up from the ground. And so for number 5 and 6, I could see it is ST and that dotted line under Z, respectively, okay? So the height becomes 12 centimeters for 5, number 5, and then the height becomes 14.5 inches for 6, okay? Then I'm going to input these values in for number 5, and just to give you a refresher on how to multiply, these kinds of numbers, all right? So for number 5, I see that it is a 2-digit number times a 2-digit number, so I'm going to stack them like this, okay? Then I'm going to do 2 times 1, which is 2, then 2 times 2, which is 4, okay? And then you can drop a 0 to help you remember to keep the 0 here or not to input in anything there. Then we're going to do 1 times 1, which is 1, 1 times 2, which is 2. Then we're going to add these values up. And then this becomes 252 square centimeters. Okay. Now what about for number 6? Okay. For number 6, I see that it is a decimal times a whole number. Okay, so 14.5 times 24. So for now, I'm just going to write out the number, and I'm going to ignore the decimal, but I'm still going to stack up the numbers as if there were no decimals there, okay? But here, I have to remember that there is one number that comes after the decimal point over here, okay? And so now let's multiply, okay? So 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. 4 times 1 is 4, plus 1 is 5. And then drop the 0 if you want. And I'm going to cross those out because I used it. So 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. and then 2 times 1 is 2. Then now I'm going to add these values up, 0, 8, 4, 1, 3. And then now what I need to do is I need to move my decimal point from here over here. Okay? So my answer is 348. Is it centimeters? Ooh, it's inches. Okay, it's squared inches, 348 square inches. All right. How was today's lesson, everyone? All right, well, I'll see you tomorrow on video. Bye.